In this project, I created a prototype that is a USB adapter to a 40-pin IDE parallel cable. The objective is to create a system in which the fans that cool the equipment are powered by the USB plug of the equipment itself. I will demonstrate the application of this prototype adapter to improve performance, but first, subscribe to the channel because I post new videos every week. So the objective of this project is to power fans via power source that will be USB. So you have the USB plug, and here you have the fans that we need to power with USB. The mechanism you are going to use to distribute the power from the USB to the fans is these IDE cables that were used to connect old hard drives and allowed to connect jumper cables. So the system works like this. You have a USB plug that have a power source with the VCC and the ground. We want the VCC to go to the fan and then to return to the ground. Because we are using several fans, it's here that we have to develop the adapter. So, to create this, we are using an IDE cable that has dozens of connections in 2 rows. And what we'll do is to connect the VCC in the first row, in the first pin, and then the ground in the second row, in the first pin. And we'll do the same for each wire. So, the first row will have the VCC, and the second row will have the ground. So, with the fan, we'll connect the VCC in the first row, and the ground in the second row. And we can connect in any pin we want. If you have a second fan, we'll connect the VCC in the first row, in any position, and the ground in the second row, the row of the ground. The first row is for the VCC, and the second row is for the ground. With 40 pins in the adapter, we can connect up to 20 fans. 20 connections for the VCC and 20 connections for the ground. So for this project we are going to need one parallel IDE cable, a cable used to connect old computer drives, one USB cable, a few jumpers that are short cables to connect the power, and fans, also from old computers that cool the case. We have 80 and 90 mm fans. And the project starts by creating this. An adapter that uses a USB plug connected to a IDE cable. The USB plug uses the first and last connector, the VCC and ground, that will connect to these pins on the IDE cable. One row to the ground and the other row to the VCC. When we connect this to a USB plug, we have the VCC in this row. Then we can connect a jumper here and another row for the ground. Then we connect another jumper and then connect to the fan. And like this, only with one USB plug, we can power all the fans we need, with power from USB. And so the prototype works, and only with one USB plug we can power up to 20 fans to cool down a small device that gets hot and don't have any type of refrigeration. I have all the fans connected, and when I plug the USB cable, all the fans start working because they are getting power from USB. Let me prove it by dropping these papers. You can see they are working. And now you can cool down any equipment I need, only with the USB plug from the device. In the second part of the project, I will implement this adapter with several fans in the router and network switch to see how the cooling improves the equipment performance and increases the speed of the data processing. Although I can connect up to 20 fans, I don't recommend using all the available connections, especially with these fans, because I'm using USB power which only works with 5 volts. In the case I'm going to demonstrate, I only need a maximum of 2 fans, but I made the adapter in order to use all the available pins of the cable. So we have this type of devices, a network router or a set-top box, and because they work 24 hours a day, they get hot. Many times I have to copy hundreds of gigabytes a day over the network. The temperature of the device gets higher and the performance gets lower because it doesn't have any cooling. For that, I created a prototype adapter that connects an IDE cable to a USB plug, so I can power small fans. So I have these desktop fans, and what this will do is I connect this adapter to the USB on the set-top box or the USB on the router, where I use the pin for the VCC and the pin for the ground that are connected for each row, one row for the VCC and the other row for the ground. And using small jumper cables, I can connect 20 cables for the VCC and 20 cables for the ground, thus powering 20 fans. These types of fans can have from 2 to 4 wires, but I only need the black and the red wire to power the fan. And with the fans working, I place them on top of the device. I can use 1 or 2, so I can move the hot air and replace with cold air. Because if I cool down the device, the performance will increase. I will place 1 fan full-time here, cooling the device, and this will increase the durability and the longevity of the device, because it's always hot. So let's demonstrate how this adapter works. So in this end is a USB plug that I can connect to any USB plug like this set-top box, and then I will use some jumper wires to make the connections on each row to connect to the fans. For now, let me get a USB extension to better show you how these work. So I'm going to plug the USB extension on the USB plug and connect the adapter to the extension. So let's connect this, and now in these pins on the IDE cable I have the VCC and the ground, so I can connect the jumper wires. Let me get 1 fan, so I'll use this fan, and I place this fan turned down so I can push cold air inside the device. I use 2 jumper wires to make the connection, 1 for the VCC, 1 for the ground. I connect to the VCC on the row outside, and the other jumper wire on the other row for the ground. Now I connect to the fan, the VCC on the red wire, and the ground on the black wire, and the fan is working. As you can see, be careful with your fingers. And now I can put the fan on the open part on top of the device, so I can push air inside the device. And after a few minutes working, we can notice that the device is colder. Because this device has a big grill on top, we are using a second fan. So we can push air with 2 fans. We place the second fan on top. We get 2 more wires for the VCC and the ground. Make the same connections, 1 to the VCC on the adapter and the other to the ground. on the adapter and make the connections to the red wire for the VCC on the fan. Let's connect this, and the ground to the black wire on the fan. And the second fan is working. Now we have two fans pushing air inside the device. And with 40 pins on the adapter, I can power 20 fans. Now let's move the router with the fans so we can connect more fans for a second device. And this device will be a television set-top box. Let's bring out the set-top box. And we can see on the back it also have a grid for air that we are going to use to push air in. I decided to refrigerate this device because this not only shows television but always run applications, and sometimes, because it gets hot, the application becomes slower or even freezes. So let's refrigerate this device. We'll use the same adapter connected to the router. We only need to get more fans. Let's get two more. So I have to place the fan on the grid of the device. Now I need two more jumper wires to make the connections, one for the VCC, one for the ground. I make the connections on the VCC on my power hub, and one for the ground on the power hub. And now I connect to the connections on the fan. The VCC will be on the red wire and the ground on the black wire, and the fan starts working. Now it's moving air inside. And be careful with your fingers. Now with this power hub you have three fans cooling down the router and cooling down the set-top box, and using only one USB plug that I can use from any type of device. The fans on the router have been working for a while. It is cooler, and on the side I can feel the cold air coming out. So the system is working as expected. Cold air is coming in and the hot air is pushed out. Let me show you the entire system working. All the fans working connected to the power hub. And with this power adapter I can power up to 20 fans and cool down as many devices I want, only with one USB plug. And the more fans I use on a device, the colder the device will be. And when I unplug the USB cable on the adapter, all the fans will stop working. And they all stop. To turn on the fans again, I just plug again the USB cable, and the entire system gets power from the 5 volts from the USB. So with my power adapter USB to IDE that works like a breadboard, and I can cool down a network switch, router, set-top box or SBCs. So any type of device that doesn't come with a fan or a refrigeration system but should be cooled down to give a better performance. And with my power adapter I can cool down the devices using its own USB plug. Let's move this back again, and if I want to shut down the system, I just have to unplug the USB cable and the system is off. And now with my network device cooler, it will give me a better performance when processing the data. It is cooler, can feel it, and the same with the set-top box. The applications will be faster. I will have less problems while streaming video, and the durability and longevity of the device will be higher. Now consider subscribing to the channel because I post new videos every week. Hit the like button if you like this project, and if you have any question or comment, write in the comments below.